Sometimes energies are expressed in units like kilojoules per mole. When you have a photon energy, that's giving you how much energy you've got in one photon. So if I say E photon is 4.086 times 10 to the minus 19 joules, that's the energy of one photon. Here, what I want to do is figure out what's going to be the energy for a mole of photons. Here's how I do that. I'm going to recognize that my starting number here is actually joules per photon for one photon. And what I'm going to try to do is change that into kilojoules per mole of photons. So it's talking about a mole of photons in this problem. Now, we know how to go from a particle or a single object to moles. 6.022 times 10 to the 23rd photons in this case is 1 mole of photons. And that's what they're talking about here, a mole of photons. And I also know how to go from joules to kilojoules. 1 kilojoule. Kilo means 10 to the 3 joules. So there's my roadmap for doing this problem. To turn it into a calculation, I write down my starting point again. Now I want to get rid of joules here. And I want to get rid of photons on the bottom. Let's work on the joules first. So if I have joules up there and I want to get rid of it, I know joules has to go down here. If I look at my conversion factor up here that relates joules to kilojoules, there's a 10 to the 3 sitting next to the joules, and on the other side there's 1 kilojoule. The joules cancel out, and then you've got kilojoules on top, so the top part's done. Now let's do the bottom part. If I want to get rid of photons, I'm going to have to put photons on top. And if I look at my conversion factor, there are 6.022 times 10 to the 23rd photons in 1 mole of photons. So if I do the calculation, then it's going to be 4.0864 whatever 4.086 times 10 to the minus 19 divided by 1 EE3, that's how I type that in, times 6.022 EE23 is how I key Avogadro's number in. And then I end up with 2.461 times 10 to the 2 kilojoules per mole. Now, I rounded it off to 4 figures because I started off with 4 figures there.